Jared, what are we talking about today?
We're going to talk about a love obsession that I have. And besides my wife.
What's this video going to be rated?
It'll be G.
Good.
Okay, so we're going to talk about expression trees, and expression trees are something that I just have fallen in love with. I fell in love with it first when I discovered Link and C#, and I came from a JavaScript background and then learned C#, and I thought, what a wonderful concept, and I could not get my head wrapped around how these functions could be called at a later time on data that's on the database and retrieved. Anyways, it just confused me. So,
and I can attest to the fact that Jared has been obsessing about these things for weeks. He talks about almost nothing else, except his wife.
There we go, thank you. Salvage my marriage. Anyways, so we're going to talk about why they're so exciting. They've also been known as a syntax, abstract syntax tree, so AST I think is what they call them. They're doing a lot of static analysis on code so that they can find errors, and that's actually done, I think, I may be jumping the gun, on these static tree analysis. And so they get your code and they build a tree with it, and they're able to analyze it and tell you where there's likely going to be a problem. But we're not going to dig into that. What we're going to do is we're going to give you a simple example. We're kind of going to get functional on you a little bit, but we're going to discuss why expression trees or abstract syntax trees are awesome. And so let's talk about functions, I guess, is what we should talk about, right?
Yeah. And this video may not be as useful as some of the others, but the stuff we're talking about really is fascinating. It's good to know. Truth is truth and is worth knowing.
That's right. I wish I could. You'll probably not gain much out of this other than maybe someday you'll run into it and understand it better because you need to. A lot of people are building querybles and C# and so forth. This is not near as in depth as that. You'll need that, but anyways, it'll get you started.
I think it'll be interesting. So
okay.
Stick around. Start us with a function then.
Okay, so what we're going to do is we're going to write out a function. First off, let's start a little geeky. What is a function? A function constitutes the function signature, and so you have. How do you like my back towards you, Ben?
That's okay. I'll come over here.
So a function signature will just represent like lambda calculus, right? We pass in an int. Let's just say int value and an int value, and we receive an int value. So that would be a method signature. It tells us what this function does. We don't know how this function works. We just know that we give it two ints and it returns us an int.
Mm-hmm.
We will know what this function does if we simply name the function. So we're going to do a simple example today called add. And so this is what we're after. We're going to build a tree out of a function that does this.
Okay.
So let's build it in JavaScript. Right?
Got a brand new whiteboard today, and it doesn't like to erase very well.
So bear with us. We had to have like Windex to clean this thing off. Or anyways, I was gonna say something else, but we won't say that. So let's go ahead and write the add function. We're not gonna write the name of the function. We'll just write the function itself. We'll keep it simple. It takes an int and another int, right? We don't have types in JavaScript, so we'll just keep it simple. And we're going to return A plus B. Simple enough, right? So that is what we're going to turn into an abstract tree expression or whatever.
You can just call it an expression tree.
I call it an expression tree. So from here, what we do is we look at it, and this is where we're going to get a little geeky. How do we write this in a functional way that it can't be corrupted with side effects? It doesn't have any variables outside, no global scope, no nothing. So you can write go ahead. What were you gonna say?
In true functional programming, a function is a black box, right?
Yes.
And it can have some inputs, in our case A and B, and it has an output, which, I don't know, we'll call C.
C. That's a good idea.
In true functional programming, when we say there aren't any side effects, it means nothing that happens inside this box can affect anything that happens out of it, and nothing that happens outside of the box except for the parameters can affect what happens inside. So for any two values, for if you were to put 2 and 3 in, you always get 5 out.
Right. I checked your math. You're good this time.
Phew. Yeah. And if we wanted to square pi,
no, dear.
I'm not going to do that.
Let's not go there. Let's not go there. But the point is that it's consistent. There's never side effects.
Yeah, and there's a name for this property, and I just read it today, but I don't remember what it is. But for the same values, you always get the same result today, tomorrow, and forever.
And imperative programming kind of goes against this by nature of imperative programming. Even though it's smaller and there's encapsulation within class and you maintain your state within your class, what kills functional programmers the most is when you say I'm gonna send your method nothing and I'm gonna get back void. A functional programmer goes,
well,
what is it doing? If it doesn't do anything, if I don't give it anything and it doesn't give me anything back,
what's the point?
I can delete that. It's void, right? So in this case, we're keeping keeping purely functional.
So imagine there's no scope out here. The only thing we're caring about is what's going on there.
Right.
All right.
So let's go on to
Tangent complete.
So now with that, how do we represent that in a functional way? So what we're going to do is we're going to create functions that do these functions, so to speak. So what we do is we say, what we start with is a function, and it has a function signature. So we're going to say we need to create a signature for this function. What does a signature need? Well, it needs variables. In this case, we're going to keep it simple with A and B this time, right? We're going to get into complex expressions and value expressions here in just a minute. We'll explain that. So in order to make a function, it needs to receive values that represent a signature and another value that represents the body. So this function takes in, so the body is basically, it can be a variable amount of statements, so lines. In this case, we're lucky, we only have one, but it's a return statement. So we need to write a return statement. It has attached to it an addition statement, so we have to add. Are we going to go off the camera here?
I think we're good.
Okay, so we're going to have the body. The body is going to have a return statement. The return statement is going to have an add statement. So we're right here, and we're going to add the variable A and B. And then I don't know how many.
I think we need one more.
Okay. So this may look a little daunting at first, but let's break it out.
And it also looks totally useless.
It does.
What does this function even do?
The reason why I say this is because what we're going to do is we're going to build what's called a visitor. Okay? And with this visitor, we should have named these correctly because you can't name that since it's a reserved word in JavaScript. So it's return. We'll just do RET. What we're going to do is we're going to build a visitor that interprets an expression tree and spits out some kind of programming language. Okay?
So let's build our tree.
Okay, so the tree is quite simple. If you look at how the steps are going to take, if you were to put this in your JavaScript console, there might be some kind of ambiguity here in which order they go. But for our case, we're going to do it the way that a tree is evaluated, and it's from the leftmost leaf. Then it works up there and then goes down the next leftmost leaf or branch, and so forth. So the first step is signature. We're going to go evaluate signature. The second step is clear over here because we have to go clear inside, right? Here's the second. We're going to figure out what add is. Third. Fourth, and then the whole thing.
Finally, we'll evaluate function. So
this is the order in which we analyze the expression. So let's build the expression tree.
Draw a tree.
Has anybody, there's this great video that Douglas Crockford did years ago that introduced me to Douglas Crockford. He did a video on walk the DOM. And he talked about how you write a recursive function to walk the DOM. And it just like blew my mind that you could build such a cool thing. And that what it would do is go to its leftmost branch and get to the leaf end and then go up and just work its way back. It's a beautiful recursive function. You should go and write it for fun. We're not going to go there. We're just going to tell you what happens if you were to write it right. So the first thing we need to do is we're going to define a function, right? It has, I don't know how far down we can go.
Oh, you're good.
A signature. It then has a variable A and a variable B.
Let's put those in quotes.
In quotes? Good idea.
Completely. There you go. Alright, then on this
Well,
side,
you get to do a tricky one. Go for it.
we're going to have the body.
Correct.
The body only has one child.
So even though the body is only one child, we'll get to that in a second, but it's still complex, and we'll explain what that means. So then after the body, it has the return and the add. Put those variables with the quotes again, like you said. I think that was a good idea.
Yeah, can you see that? This is A and this is B.
That's A and B. I hope they can see that. So let's talk a little bit first off about complex expressions and value expressions. Value expressions are reduced to a value. It means I cannot be reduced.
Yeah, essentially what we want to do here is evaluate this expression. And evaluate means turn into a value. Because, so these are already values. There's nothing to do here.
Right.
Can't break these down. They're simple value expressions.
Correct.
This is a complex expression because it has not yet, we need to do some work to turn this into a value.
Right.
And the same for this, and this, and this.
So let's say, for example, so the difference between complex and values is that complex can have arguments, basically. So you've noticed something, complex expressions can really just be a method. That's what they really are. If you're to look at, okay, a function takes two parameters of sign and body, right? Of signature and body. And signature takes two value expressions, not two, in this case it's just two, but it could take a variable amount.
Any
right?
number of, yeah.
Any number.
expressions.
And the body, for example, we only have one statement inside that function, but there could have been 50, right, of different things doing things, but only the return, we're only doing one to keep it simple.
Actually, in a purely functional language, the body could only have one.
Do they not have a variable amount of parameters that they could
Well, this is all, the body, the function body is all going to evaluate down to one value.
Oh,
I guess
sure.
you could put stuff on there, but
Sure, it's,
in
yeah.
a world without side effects, it wouldn't do any good.
Okay,
Okay,
so,
sorry that was a horrible
was
tangent.
but anyways, good enough said. So what we're going to do is this is the step, remember how we went and said this happens second. So if we're just to go down this again, this is the first step, because we go clear down, but remember this is just a value. We get to this point,
There's
we're no reducing to do.
no value, yeah. So then, add is 2.
Yep.
The next thing to be evaluated is,
The return, it's a sharp tip there.
I need to evaluate me a new marker. 4, and then finally,
The 5.
5.
So now with this knowledge, we can build ourselves a visitor. And that's what we're going to do next.
Well, let's ask the question first. Why in the world would I want to build an expression tree in the first place? And if I did, what would the visitor do with it?
Well, in our case, we use it for querybles, but in this case, you could do it for anything. In this case, we could actually we can turn a function that we just described in JavaScript, built an expression tree out of it, and now we can actually turn it to any language we want.
So just like we use JSON or XML these days to turn data into a transportable format,
Yes.
we can pass values around. You're saying that with this expression tree, we can package up a function or a formula
Right.
and make a transportable function that can be easily interpreted by anybody?
Right. So yeah, exactly. So this expression tree can be consumed and then output anything. You could I think they're actually doing this for I shouldn't say anything because I'm not quite sure, but this is the way that you can actually take one language and translate it into another language. So you could take C to JavaScript because they break the C down into a bunch of statements that's translatable to another language.
And when you think about it, it makes sense because whatever language you write in, there's no end to the number of computer languages, programming languages there are. What does that eventually turn into?
A set
Machine
of
code.
instructions, yeah.
So it all gets compiled down to something the same. Whatever language you start in, it's all going to end up the same. And as it turns out, that thing that it ends up as is basically an expression tree.
Right.
That the CPU runs on.
Precisely.
Yeah, okay. So we're going to make this transportable so I could build one of these on my client side in JavaScript.
Right.
For some reason. And then shoot it across the wire.
Right.
And then the server could take it in and then turn my JavaScript code into something else. We should write a little demo where you can write stuff in JavaScript and then we'll spit it back for you in another language. I should do this on our website.
No, that's a good idea.
That's an idea I just had.
So let's do
Ideas
it.
live here, people.
I mean, you could actually translate this into SQL. I'm not a big fan of stored procedures, but I'm sorry if you are, but I'm not. But you could literally turn this into a stored procedure in SQL. It's like endless, really, with what you could do. So if we could remember this simple function, or what we're going to do now is we're going to write the visitor. Now the visitor.
I'll put this over here so we can.
Okay, so I'm going to get erased and then you can write it again, right?
Let's keep our tree though.
There's a tree. Can we fit it all?
Maybe.
Okay, so we should have probably, I'm not even sure if that's on there, but I'm going to get going. So what we're going to call this is that, I'm going to go as high as you right there, if that's okay. Yeah, you're right there. You're perfect. I think so. Put your hand there again. No, you're off right there. No, the curly brace is off, so you're good. So you're just right on the edge. Okay, so what we're going to do is we're going to just create an object literal in JavaScript, and we're going to call it visitor. And we're going to write the functions. We only have to write 5 functions to actually interpret this expression. So I'm going to start right there. We'll say our visitor is equal to an object literal. And it has to have a way to implement a function. Well, let's do function. This kind of looks funny, doesn't it? And a function has a signature and a body. So let's keep it real simple. I bet we could get into there. And what's the next one that we need? We need a way to do a signature function. And that takes a variable amount of parameters, but in this case we'll just do it simple. We'll just do x and y so we don't confuse people with variables of a and b. Okay.
Hang on, the aha moment is coming, I promise.
We hope. Okay, so now we have another one which is body.
Body return and add, and I'm going to get rid of this because we're going to run out of it.
Okay, function. The function actually, in this case, is just going to take one. We'll just call it the statement. And the
add,
return
and add.
Okay, return. Oh, they're gonna try this on their console and be like, "That didn't work." Okay, return's gonna be takes any statement. Anyways, okay, let's do another statement. Expression. Okay.
And then finally add.
All right, now to what we're trying to do here.
An actual useful visitor would probably be much longer than this.
It would. I think the one that we have for our querybles has probably about 30 functions or so.
Yeah.
But it does all sorts of greater than, less than. It does lots of interesting stuff. So let's do X and Y.
We have another video about the querybles, but in case you haven't watched it, what we're talking about are these structures that we can write in JavaScript, in actual native JavaScript code, which are then turned into an expression tree sent across the wire onto the server, which translates it into a link expression in C#.
Right.
Which then
goes
I guess
to
we're
entities.
using OData.
We use OData, but then OData gets translated to
C#. And then off to entities. So it's a query that we write in code, not in SQL, that we can transport everywhere, anywhere. Right. If we change the back end, we wouldn't have to change anything in the front end code because we use these generic queryable to describe the query, and then the expressions from the expression trees from those queryables get turned into whatever query language they need to.
That was an awesome tangent.
If you haven't watched that video, you probably skip it now.
Well, yeah, that was a lot better. Well done. An applause. Okay, so right now, Ben and I are actually going to step through this. Remember how we had that expression? Can they see right here?
Yeah.
Maybe. Okay, so I'm just going to write that expression over here real quick. So we had the function, which had a signature, which had two variables, A and B, right?
Uh-huh.
Then you had the body, which had a return value, which had an add statement, which had A and B.
So what this visitor is going to do is take this tree and turn it into JavaScript code.
Correct.
We're doing string manipulation here. So we're actually going to write a string that represents, hopefully, this function right there.
So you remember that line that I had written along here that had that really long is like nested, nested, nested. That's essentially what would happen if this visitor gets launched on this tree. It's just going to consume it in that order. So the first one that we did was signature, right?
Yeah.
So let's write that. How does the function signature, should we write it in JavaScript first?
Yeah, let's do JavaScript. And if you want to do that, I'll start down here.
Okay.
Let's just fill it in and then we can...
Explain it. Okay, so you fill it in. I'm going to fill this in. We hope that our... I'm going to be peeking at yours.
As it
Okay. So we do the plus. Y. Alright. It's too simple, isn't it?
It is. And it's really hard to read because there's a lot of plussing going on. Okay.
That looks great.
Then the return.
Yeah, sure.
And then the function.
Oh, and the function is. But what I like about this is if you look at this, how simple it is, it makes your head just kind of turn in and on itself. And you're like, wow, this is quite simple. Because all you're thinking about is how do I write this for this particular case. So if I want to write a function, this is how I write a function, right? I write a function, then I say I need to add my signature, and then I need to add my body. But remember, this, by the time it gets to here, it's all been evaluated down to a value. So like Ben said earlier, it's been evaluated. The function doesn't get called until the signature and the body is completely compiled. So let's go down in the order.
Let's run this program.
So if you'll notice, we're always returning strings. So if you remember right, the first thing that we called was signature. So sign is called, and so let's write this out.
I'll write it over here and we'll see if it matches.
Okay, so the signature is...
Call the sign function with what's x and y.
Yep, x and y is a and b.
Okay, so I had a parenthesis and a and a comma and b and the closing parenthesis.
Okay, so the next thing that we call is we hop over to the body. Okay, so now...
There's evaluation to be done here.
Sorry, actually down here.
So we're going to go down there.
Sorry, we had to go to the innermost left wing.
Okay,
so now we're add.
Add.
So now we're down to add.
X and Y again are A and B, so I'm going to have A plus B.
Yeah.
I even did a semicolon.
I'm not sure if I did things right. Anyways, okay, I think I did. Okay, so then after that we go to the return statement, which now it takes, so after it calls add, which then gets passed, so this return statement here actually gets passed into here. Okay?
And this was what that made.
Correct.
All we're going to do here is add return on.
Correct. So this is actually going to be fun. So return then takes its statement and throws it here.
To body, which gives me...
The parenthesis there, or the bracket, I mean the curly bracket.
Yeah, I'm just pretty printing this for your sake. he didn't actually do like carriage returns and everything.
That's right. I should have put the.
Okay, now we got, now this right here, all this constitutes the.
So this comes here, and this comes here.
Here's the body, here's the signature. Now what do we do?
We just put function in front of it. So, kablamo, we just built, that seems really pretty stupid to write all this code to write that. But the point is you can actually translate this into any language.
We wrote a function in JavaScript that writes a function in JavaScript.
That's right, and it's actually executable.
Yeah.
That would be an anonymous function that couldn't be called once it was executed.
You could, yeah.
Anyways. But the point is we actually built it, and so you could do this with any language. Did you want to try another language real quick?
Yeah, let's do Python. We might not actually do this because you guys are bored to tears already.
Okay, so.
But let's pretend we go through there. We've already got the JavaScript one.
Okay, so we'll step through it again. Our first one was the sign, the signature.
The signature, okay. We tried to choose a language that doesn't look like C.
Right.
And Python is less C-like than some, but it's still going to look pretty similar. Okay, so the signature actually ends up being exactly the same.
Okay, and then the next step was we went to add because we have to go clear down into the body of the.
Okay, add. Oh boy, we should have chosen a different language.
Okay,
A
then
plus
the
B
very next
again.
thing you got to return that.
Okay.
I don't know how you return. Is it
Let's still return.
Oh, wow, okay, well, we're looking quite similar here. Then it gets passed to the body.
Okay, now this is different.
Okay.
Because in Python, there aren't curly braces, it's all depending on the number of spaces.
Oh dear
you
heavens,
have.
I would not do well.
So this visitor, it's going to be really complicated in Python.
Ooh, because of the tabbing.
Because of the tabbing, you'd have your visitor to have to know where it is. And okay, so I'm going to put a colon here and some white space there.
Okay, so we've indented. That's perfect because you can actually do that.
Yep.
You would know that you were in it. Okay, now after that we go clear up to the top now because we've got the signature, we've got the body completed, right?
Uh-huh.
Now we just need to write how you declare that function.
And that is as easy as saying def.
So that's it.
We've obviously simplified this a little too far because you need the name.
Oh, they don't have anonymous functions.
Def add. There's no
Okay.
anonymous functions in Python.
Sorry, so we should have put another parameter
the
up
signature,
here.
the body, and the
name. So, well, actually, the signature should have been part of the. Sorry, it's part of the signature maybe. Anyways, you could add it anywhere you want in the expression tree. We're good.
You can have a return value on your signature.
Yes, you could. We've really oversimplified
Yeah, this
this.
is way too simple.
But this is the cool thing about expression trees. When we started out with queryables and we were doing all these queries, it actually started really, really simple. And I thought, oh, I can do that. I can do greater than, less than, substring of. Oh my word, GUIDs. Oh, and it just got more and more complex. But I was able to grow the way that the queries were built through these expression trees because I was like, oh, I can just put another parameter inside of the method of signature.
Yeah.
And it just works out. So that is it. I don't have much more to say. It's just other than it's really exciting to me. That's about it, I guess.
It is useful somewhere, but it's kind of cool. And I don't know. I think it's kind of cool that with this visitor pattern, which by the way is another gang of 4 pattern.
Oh, and this is a composite pattern.
Another gang of 4 pattern.
So we're just teaching patterns.
That's right. We're just applying some patterns
Two
in
patterns.
a very academic way.
Ways.
This was good for you.
And you will enjoy it.
Yes. You will have enjoyed it because you've already watched it.
Was Madagascar of the penguins? Anyways.
Yeah. Bye.